Hello friends, I welcome you all to watch my new video, and in this topic we are going to cover electric field on equatorial line of dipole. So what is equatorial line of dipole? As we have discussed earlier, the equatorial line is perpendicular. That was the dipole axis earlier, that was the dipole axis, and this is perpendicular. Okay, so perpendicular to the this charge dipole axis, means this is the dipole axis, and it would be perpendicular to the dipole axis, then it is called equatorial line. Okay, and here on equatorial line at point A we have to find out electric field, total electric field due to these two charges. So how we will calculate that? As you know that this distance, let's assume this is center of dipole, and this is distance r. Okay, that distance, this is the point equatorial line of, this is point A, and this is at this point we have to find out the net electric field. So this is at a distance of r, and as you know, distance between these two charges is 2a, and from center of dipole and minus negative charge it is a, and likewise from center of dipole to positive charge it is plus a. So if this is a right angle triangle, as you know, and this is theta, what will be the hypotenuse? So from Pythagoras theorem you already know that this square means base square plus length square will give you hypotenuse length. So here we have mentioned that r square plus a square, and we have taken under root of that, and this is the distance. So we have to calculate the electric field at A, we must know the distance from negative charge to this point. Okay, point of interest, and this is r square plus a square. Likewise, this distance, if this is the right angle triangle, this will, if this distance is a and this distance is r, then hypotenuse will be r square plus a square, and you have to take root of that. Okay, so you know this distance. Now to what will be the magnitude of the electric field? Okay, so as you already know, at any point of if you have to find the electric field, what you have to do? You have to simply multiply k and the charge q, okay, and divided by distance of between charge and that point. So if we have to find out the magnitude of this charge, magnitude of electric field at A due to positive charge, what will happen? This will simply, from electric field definition you already know, kq upon r square plus a square. Okay, likewise, and electric field at point A due to negative charge, what it will be? kq upon r square plus a square. Okay, this is clear. Now we have to find out the net electric field at A. So we will add both these. How we will calculate net electric field at A? Okay, so as you know, if you will see this figure, due to this positive charge, electric field at A will be radially outward. Okay, because electric field will be radially outward, as you already know, and due to this charge at point A, it will be radially inward. Okay, E minus Q. Here you can see E plus Q, and this is E minus Q. Okay, and now you have to find out, if since this is not in a line, so we have to take, okay, their cosine and sine. So how we will find out? Okay, so if you will draw, if for this E minus Q, for this charge, for this electric electric field, you have to take cosine and sine component of this term E minus Q. What will happen if this is theta? Okay, if this is theta and this is a triangle, what is this? Is length, this is base, this is hypotenuse. Okay, so what will be the sinusoidal component? This component will be the sine component, E minus Q sine theta, and this component for the electric field due to minus Q, cosine factor will be this axis. Okay, EQ minus cos theta. For minus EQ, this is their sine component and this is their cos component. Likewise, for if we break this electric field in two components, sine and cosine, what will happen? This is the sine thing. This is the likewise. This is your angle. Okay, and this is your triangle, right angle triangle, and this is theta. Okay, then what will happen? This component will be sine. Okay, and it will be in this direction. Okay, and what will be the cosine factor? This E cos theta. Okay, so now you can see that cosine component of both these charges are in this direction, and sine component of these two charges are cancelling each other. One is in this direction, positive charge sine component is in this direction, and negative charge sine component is in this direction. So what is happening here? They are cancelling. They are equal in magnitude, but they are cancelling each other. Okay, and here, so what will be the net electric field? Okay, so due to this electric field due to this positive charge and electric field due to this negative charge. So EQ cos theta and E minus Q cos theta. Okay, so that's how we have here written net electric field. What is net electric field now? The positive charge EQ cos theta plus E minus Q cos theta, and as you know, this sine component is cancelling each other, so we don't need to consider them. If you want this discussion included in this, then I will make another video, but for time being we will simply consider this one, 2E cos theta. Okay, E cos theta plus E, because E of both the positive charge and this one is same, so we have simply added 2E cos theta. And what is the value of E? If you will see, E is nothing but due to this charge. If we have to find out electric field at A, what will happen? Simply you have to multiply K, Q, this charge, we are not taking the sign here. Okay, KQ upon this distance. Okay, from point A to negative charge. This distance is R square plus A square. So what is this? 2KQ upon R square plus A square. Okay, this is your magnitude. And what is the for cos theta, what you can write? Just have a look on it. See, if this is the triangle, okay, and this is the theta, what will happen? That if this is the base, this is the length, and this is hypotenuse. So cosine factor is base upon hypotenuse. So what is cosine theta? A, this distance is A, already you know. Okay, and this term is R square plus A square, you have to root. So instead of cosine theta, you can write A upon R square plus A square, you have to take root of that. Okay, so that's how we have written here. 2KQ R square plus A square is this term, and for cosine thing, cosine term, we have written A upon root under A r square plus A square, and this is power 1 and this is 1 by 2. So if you will add 2kq A r square plus A square to the power 3 by 2. Okay, but as you already know, dipole moment is already, you know, definition is q into 2a. Okay, so what is this? This is dipole moment. So if you write q into 2a, you can simply write this as p. What is this? Electric dipole moment. Okay, and kp upon r square plus a square upon to the power 3 by 2. Now, as you already know, as we have discussed in dipole axis derivation as well, that as you know that if you take r here is much greater than this distance. Okay, the distance between these two charges 2a. So r is much greater than this 2a. So what will happen? Electric field, net electric field will be kp upon rq. Here this expression a is ignored, and this r, if you simplify these terms, then what happens? R is r cube. You will get this term. Electric field is nothing but on equatorial line. Net electric field will be product of k electric dipole moment upon r cube. Okay, and if you will see, I have taken here the negative sign before this term. So what this indicates? So negative sign indicates that electric field direction. Okay, electric field direction, if you will see, electric field this is in this direction, whereas the dipole moment is in this direction. Okay, so the electric field is in the opposite direction of electric dipole moment direction. Okay, so just to accommodate these things, we have taken the negative sign. Okay, earlier in dipole axis case it was positive, and in equatorial line it is negative. So net electric field is inversely proportional to the cube of distance from the center of dipole to that point of interest, that is A. So I request you, please do like and subscribe. I believe I have explained these things in very simple manner. So please keep watching, do like and subscribe. Happy learning. Thank you.